So let me go ahead and I'm going to walk through the distance learning plan. And once I've walked through the distance learning plan, we'll take a deeper look at what the activities are, and then we'll talk about how they would fit into a potential calendar. Okay, so we'll start off with this is the unit on reactions. And so as usual, our interactive notebook is in the upper left-hand corner, and we'll open that in a minute. The activities that we're going to go through is we're going to start off, there's a unit opener slideshow that's on primary and secondary pollutants where we talk about what kinds of pollutions we see. And it does sort of start about like, how does the air look like now where we are in Portland versus where it was at the beginning of the year. And if you recall those days at the beginning when we had the giant fire, I'm sure people will remember having to be stuck indoors, so that will still be applicable. Then we go through sort of this intro into pollution and different kinds of pollutants that exist. The next thing is talking about how those pollutants are made. So there's a go formative activity where we walk through and we sort reactions by similar types of reactions. And we do that in that go formative activity. Then you'll sort of learn how those reactions are made. So we start off by reading through what chemical reactions are and the signs of reactions. There's also like a video to help you sort of solidify what those kinds of reactions are. Then you move into predicting what the products of reactions are. There is a lab that we used to do. There's a virtual lab, but I would recommend the Go Formative scaffolded shortened version of the predicting products. You can choose which one you want to do. I'll talk about the shortened version while we're here and how that relates to the other one there. Then there's a simulation you can do. There's also this mystery dropper lab that you can do. I recommend doing both because students often struggle a little bit with the predicting products, and so a little more practice helps. And then there's this predicting products activity. There's a quiz and a key for like having them work through, and they usually need a little bit of help to kind of get started and support on that. So that's usually a good live activity. Um, Versus the mystery dropper lab, there's a video talking about how to do it. You can demonstrate it once, and then once they get the hang of it, they can do a lot of that work themselves. After that, we talk about balancing equations. So there's the balancing equations PhET simulation you can go through. Then you'll want to have them do practice on balancing equations. So there's some leveled practice sheets here that also talk about how you might want to do it if you're having students who are struggling with how to balance equations once they've gone through this PhET simulation. There's a couple different support activities here for helping them learn that. There's one where you're using different kinds of pictures. There's another one where they look at counting atoms. Either one of those works. This is more of a table method. This is more of a picture method. I've found in the past that my students need a mix. There's probably a third of them that go really well with the picture balancing. A third of them, it drives them insane. So they need the counting atoms version. And a third of them just like they can look at an equation and just sort of figure it out in their head. So you'll want to make sure that you sort of level that based on where students are and let them work at their level for that. Once you're done with that, there's this piece around the nitrogen cycle, this balanced or unbalanced. It kind of walks them through what's going on with nitrogen. And there is a key that it is in the teacher folder, in that restricted folder. We don't have an engineering practice for this particular unit, mostly partly because of time and partly because there hasn't been one that features well with distance learning at this point. So that's where we would sort of end this time, so we don't have that final piece on there. Are there any questions before I start going through the actual unit? It looks like there's a couple people that I need to admit into the thing that I didn't quite get earlier. So welcome Jeannie and welcome Steve. Sorry, I just went through the overview where we talked about the different pieces. I'm gonna pause the sharing for a minute. Oops, I said stop sharing and I was supposed to keep sharing, and let me go back to sharing my screen. I did the wrong thing. I'm going to pause the recording. Okay, so now that I've dropped the link in the chat for those of you who need it, I'll go ahead and start going through the pieces as they go in the planner. So the interactive student notebook, when you open it, it looks like this. It has those different pieces. And as I've said in other webinars, you might want to break this up into smaller pieces for your students. I recommend keeping whatever terms match that task set with the task set. So like primary, secondary, particulates, those will all want to be part of task set 1, for example. This first, and yeah, I also like to keep the unit question with there. So like how are pollutants produced might you want me to put with task set 1. So it starts off with what are the sources of pollution? And that goes through those unit opener slides. So let me show you what those slides look like. So it starts off with talking about the air quality at the beginning of the year versus today. And I think this might have been, yeah, so this is September 2020 when we were all like shut inside our houses, feeling miserable about everything. And then it goes into talking about air quality, um, where pollution comes from. What have you heard about pollutants? There's a video about pollution that you'll want to watch with your students. It's about 5 or 10 minutes long. And then you just have a discussion about, you know, what do they want to know? What are some questions that you can either put on a Jamboard or to have people put in the chat if you want, or have them unmute and talk. And then it kind of talks through all of those pollutants, like what are primary pollutants as you go through there. So that's kind of what's going on in this slideshow. And this shows you a lot of the different primary pollutants that you could look at, and you can go as deep into that as you want to while you're going through there. So once you've gone through there, you want to talk about the differences between primary and secondary pollutants. Um, and that's what's going to go in their interactive notebook. So I usually recommend that for this first one, the unit opener, since you're going through and you're sort of talking through this and letting them know what's going on and explaining about the different parts of pollution. I usually do that. I would do that as a live session piece to kind of introduce the unit and let them see what's going on with the unit. You can have them start off with it as a live session and then have them read through the rest of the slides as an asynchronous piece. That's another way of doing that. Introduce it and then let them finish reading through all of the background information in these slides. The next thing that the distance planner has us do is go through and read these pollution text sets. So this is what I would suggest to do as asynchronous. So there's a set of different, if you go into this folder, there's a bunch of different texts that you can assign to students and have them read through and do like a claim evidence reasoning for their particular pollutant. So they're going to do like a report on like what is this caused by and where is this coming from exactly. If you don't feel like doing that, the other way to do that is this Go Formative intro, which I think I actually have already opened, where they go through and they watch the video, they go through, they look at the slides, and then there are some links to some different readings that they can do. And then they go through and fill out what are the different forms of pollutants. So this is just sort of having them go through and read that and understand where those pollutants are coming from. So that lends itself to starting it out as synchronous and then letting them finish it as an asynchronous activity. Once you're done with that, you go on to task set 2. And task set 2 are sort of the essential question is how different pollutants are made. And this is where we're filling in with the different types of reactions and how they relate to those pollution activities. So we start off with this pattern sort. So it starts off with this, and this formative is just the link that came right here, the Go Formative Chemical Reaction Sorting activity. And so what they're doing is this first activity, they're going to sort these equations into 5 different groups. And you'll want to talk to them about when you get them started, and you can set them up to have them do this as a synchronous or an asynchronous activity. If you're doing it synchronous or live, you might want to put them into breakout rooms to have them discuss it with their peers as they go through it. That's how I would do it. If you're going to do it asynchronous, then you can just have them do it on their own. I think that the discussion is valuable. But you'll want to make sure to tell them that each group should have some sort of a number version, some sort of a letter version, some sort of maybe a picture version. so that they have each one of the different flavors of equations in this first part. And this first part is trying to get their mind primed for how the different patterns look like when we go to actual equations. And so and your tag students will generally go, oh, wait, the second activity that we sort through is just the first one. I'm just using elements. Your other students, you'll need to kind of help them along to come to that realization. So they go through and they do that, and they sort of, and I'll expand this to show you what that looks like. And then once they've got it, they put in what the categories are, how they would describe them, and give a sample equation. So you'll want to check it before they move on to the next step so that you can see, like, there are other ways to do it, but you want to try to either guess yours or come up with reasons for why some of the things that they put together may or may not be the best kind of grouping. So that's usually what you do with that. And then they're going to go on to do the same thing with the chemical equations challenge. And these are the same, those 5 groups of kinds of reactions that you're going to see. So you're going to have synthesis, decomposition, double replacement, single replacement, and combustion. And these are set up so that they match the patterns in the previous sort. So like if you look here, you'll see for this synthesis equation, I've got one compound plus another compound gives me this compound. And I know that these are not balanced. And if that bothers some of your students, let them know they're not going to have the same number of elements. I'm just looking for a pattern. Okay. So if I go back up here, you'll notice that I have a similar pattern of I have 2 things that add together to make one thing. So that's that synthesis equation where I'm putting them together. And so once they've gone through here, and then you want to go through and have them categorize it again, and then explain what their groupings are here. And then afterwards, you can talk about what the chemical names are for those groups and have them watch this Mirabelle video where she goes through and sort of explains the types of chemical reactions. Or you can do it yourself or have them do it, or a little bit of both. I find that it works better to both have the teacher explain and then have a different voice explaining the same thing in case I didn't quite get it from me. Also, it's a thing that they can look at later if they need to. In the unit planner, in the interactive notebook, they're going to be copying those boxes. They're going to do the activity, and then they're going to come in here and kind of summarize the different kinds of reactions, the description that they give those reactions, and the symbols that they would put together. So that's the summary that they're going to want to need of the activity moving forward to be able to start predicting the outcomes of the reactions. Task set 3. So once they've gone through that, then they're going to go into, they're going to get a little bit more practice of just like indicating what the reactions are. And so if I go into this Go Formative Chemical Pollution one, in this activity, so there's a text over here, and then they'll answer all their questions over here. And so you read through and you'll have like, what are the main causes of them? There's a link to an acid rain article that they can go through. And then it's just mostly identifying, like I can identify that these are both synthesis reactions. How do I know that they're both synthesis reactions? Because if I click on this button right here, it'll get me to that question. How do I know? Because both equations, both equations have 2 things that join together as one. So that's what they're doing in this. They're just going through and doing a lot of sort of reading back through it and identifying what kinds of reactions are there. Now, once they've gone through and they've like sorted things, identified what the reactions are, practiced saying what different kinds of reactions are, you'll want to have them go into this virtual lab. Now, when you click on that, that leads you into this virtual lab, which takes you, let me go back to the beginning of it. This is what it looks like when you click on the link. The parts of it you want them to read through at this time are the chemical reactions and the signs of a reaction. Don't have them go further. They'll be doing the experiment on a different day. So, and there are supports for what that experiment looks like, and I'll show you that. But this is really just once again reaffirming what the types are, and then what the signs are, like a precipitate or bubbling, change of color, that heat, light, those kinds of things. So once we get past that sort of virtual lab, we're actually going to go into actually predicting products. Welcome, Inga. Sorry that I didn't see you right away. So for this predicting products lab, the Go formative version, so the actual predicting products lab has you go through a bunch of slides, and that was more related to what we were doing in there. But the Go formative scaffolded version, which I have linked here, what you're doing is you're going through and you can see sort of what the reaction is, and you're predicting what the answer is going to be. And these relate directly to, if I go back into that thing where we read the chemical reactions and sign of reactions, that's what this experiment is right here. So if I go into this experiment, it says drop a piece of zinc into a test tube containing hydrochloric acid solution. And if your students can automatically put that into what a chemical equation is and write that out already, that's great. In the past, I've seen that mine are not quite there. And so here we've taken the zinc metal and the hydrochloric acid and put in what the chemical symbols are here. And then they're just supposed to go in and figure out what is it going to make. Now this version, since I copied it as the teacher, it shows the answers, but obviously if I was going to go through and look at this like a student, it's not going to have those pieces in there. It's going to have the big idea, it's going to have the video, and then it just has like, which one of these are we going to do? Okay. And it shows that if you look at this, you can kind of see, if you click on the picture, it makes it larger. So when your students are like, I can't see what's going on, tell them to click on the picture. It'll make it bigger for them because they will complain. And then they should be able to see that when I drop this in here, I can see these bubbles forming. So I know there's a reaction going on, and that'll let me answer that question. So that's what's going on in that activity. I believe if you do the predicting reactions lab, this has been set up. You can do it with just the longer version of having them go through all that, but I think this is the version that I would do. Afterwards, another activity you can have them do is this mystery droppers lab. So I'll pull up the slideshow for that, and then I'll show you what the lab looks like. In the mystery droppers lab, they're doing what we would have done in a live classroom. Is a lot of people have this lab that they've done in the past where you make a little matrix where you have well plates and you drop little droplets into the well plates. So this is relating sort of what happened in that predicting products lab to these well plates. So here I've got these well plates, and I would have added drops to them all from here and drops to them all here. And then I would use that to figure out what's in the mystery droppers. So that's what those slides look like. But let me show you what the actual lab looks like. So in the case of the mystery droppers, and if I reload this page, every time you reload this page, it reorganizes where the droppers are. And there's a little bit of like, once you figure out how to do this lab, it runs really well. But several people, so just want to tell you right now that there is a video that's about 12 minutes long, so that later when you're actually teaching this and you've forgotten everything I say, go back and watch this video and it steps you through how to do this. And you could even post that video for your students if you feel comfortable doing so. But what you're going to do in this is it says, and let me pull up the interactive notebook and get down to where that is in here. So in the mystery droppers lab, here's the link to the virtual lab that you're doing. And it has the link to the video if you want to give it to them as an asynchronous lab. You can, most people, the video is very comprehensive. I felt like it was really easy to understand, and the students who have gone through it have understood it fairly well. So I think that you could just have them do that. What they're going to do is they're going to come in here, they're going to click on these droppers, and then they can just, if they click on the little dots, it makes a little thing saying, if you see, if you watch for a second, you can see it fills gray for a second. That means I'm simulating putting a little bit of chemical in each one of these well plates. Now, if I want to add one of these other chemicals to it, I can take this dropper and I can add this to this well plate or to here. And you can fill out, all of these go here, all of these go here, all of these go here, and then fill them across. So I would want to vertically say this K2CO3 fills all these 5, and this PbNO3 fills all of these 5. And then once you've got them filled vertically, you're going to fill them horizontally. And then what you want to do is, if you click this across, it makes the background black so that you can see white precipitates. And and then if you want to see if you have a gray or a black precipitate, you can change it back to being white. That's what these little arrows at the bottom do. Now let me show you what it looks like when I'm doing that. So I'm going to clean this out. If I click on this Q-tip and I click on here once, it just selects it for future reference. But if I click on it twice, it cleans it out. So if I take this K2CO3 and I drop it in here, and then I take this PbNO3, I drop it in here, you can see that now I've made a white precipitate. So I know that that's kind of a reaction. And that's what you're doing with those droppers. Then once you've done all of the reactions, you record your observations in this table by clicking on you click on this, you click here, and then I click to my pencil, and it'll allow me to put in a label for that. And X is no reaction, G is gas bubbles, and you can see little gas bubbles that form with some of them. W is white, Y is yellow, B is for black. So here I would put W for white. Come on. And that would record on my sheet here as white. Now, I'm not expecting people to memorize or know what those are. When you're getting ready to record it, if you go back to your knowns button and your discussion, wait, is it discussion? No. When you go back to the original part of this, it tells you what all operating, if you click on operating the simulation, it tells you how to do it, and it gives you that key for what those observations are. Now, if I click back on unknowns, you'll notice, if I go back to knowns, so here is my knowns, and I have lost all my work, okay? So you want them to fill this out and record all their observations before they click on anything else, okay? And then it says in the interactive notebook to do a screenshot of what their well plate looked like and what their observation table looked like. And that's because every time I reload this mystery droppers, it changes the order so that it's different every time. So you can just, in the video, it tells them to do like Control F4 to do a screenshot. You can have them do Control Print Screen to do a screenshot, something so that it records what they've got and where they've got it and what all their answers are. Because when they get done with this part, they're going to go in and do unknowns. And what it does for the unknowns is it scrambles these again and then puts them in here so that you're doing the same thing again, but then you're looking for what made the same pattern so I can guess what the answer is for each one of these activities. So you'll, once you've figured it out, you go in to check your results and you say like, oh, maybe this is, maybe this was K2CO3 or whatever, it matched that. And then you can check your results and look, I got all of them wrong, right? So you should be able to find, and when I was playing with this earlier, when we first were looking at it, you should be able to take data and be able to say like, oh, there's one of them that makes a gas and makes a white precipitate and makes 2 white precipitates. So I know it has to be this specific chemical. So they match up decently. So since there's a video for how to do it, you could assign this one first as an asynchronous, or you could assign the other one depending on how you feel like your students are. I recommend at least a few minutes of explaining how those work. in a synchronous class before you have them go into it asynchronously. But once you've explained it, they kind of seem fairly uh, straightforward for how to do those two labs. So I've kind of put one as a synchronous and one as an asynchronous as a result. I find that those labs are good experiences, but this predicting products practice is a little tricky for students. So there's both a paper version, which I'm showing you right now, that you can have people do, or there's also the Go Formative version, which is what I would recommend for this distance learning, as it's a little easier to manage on a computer without having tabs and things to write things down. So in a minute, this should come up unless I already have it up. So it usually comes up as you'll need to copy it as your own so that you can assign it to your classes. And then the Go Formative has that same paper, but then you can answer things in the Go Formative. So it's a lot easier for students to submit. A lot of times if you have a paper document, people get confused on how to submit that document and how to turn things in. And I've had a lot of questions around that. So this gets around that. It also allows you to have there's a lot of like little videos that help support what is going on in these scenarios. So I recommend the Go Formative version for that. I also recommend that when you're doing the predicting products practice, that would be better as either a live session or small group session, because in the past, I've had a lot of questions about how to do it and what to do. And very few students can do that the first few without a little bit of help. So you will need to do some support on that, because taking that extra step to be able to figure out what's going on doesn't always come naturally to the students, the 10th graders that I've been teaching in the past. All right, so once you get past there, you go into this PhET simulation. The PhET simulation is the balancing equations PhET. As you can see, this loads up quickly because it's an HTML5 PhET, so it runs on the Chromebooks without any other pieces. You can go through the introduction piece, and basically you're adding molecules, and your goal is just to try and get it so that the equation is balanced on both sides. Now you can add some different tools that help along with that. So you can add these scales and say, oh, look, I have 2 ends on this side and 1 end on the other side. So this is saying how many N's or H's I have on either side of the equation. If people find that confusing, you can also do this version to kind of give them a better sense of what's balanced. And as you add things to it to get it balanced, you can see that it'll show you when the equation is balanced to give them a little practice on what those look like. And this has it has 3 equations that you can do as practice, and then there's some more games that go at the end. So that's that PhET simulation. Then once you've done that, you'll want to give them some practice. I find that once students get balancing equations, there's probably somewhere between 25 to 60% of the students I've had can just be like, okay, now I can balance things. And then there's a small group that needs some additional help. And that's why I recommend either there's this Jamboard one that goes through where it talks about picture balancing. And there's this counting atoms one where it's the more traditional using a table in order to balance equations. The last thing that is on this unit planner is this dead zone in the Gulf video, and then it has this sort of balanced or imbalanced activity. And that once again kind of is supposed to hammer home that what's going on and whether or where nitrogen is going in the oceans to kind of get a sense of like balanced or unbalanced. And so what you're doing is you're having them go through and balance these equations and talk about where nitrogen is going. This helps to support some of the Earth space standards as well, because it's relating back to where the atoms are going and how they're cycling through our environment. So this is set up as a Google Doc, so they can go through and just add the numbers in here and read through what's going on for that activity. And that should wrap it up for what's happening in Unit 5, which is the chemical reactions unit. Now, when I went through and planned out what I would do if I was teaching this, I came up with sort of this sample unit calendar so that I was thinking that doing the opener as a live synchronous session so that you can get some engagement and you can decide who's going to get which texts to read, and then having asynchronous for them to read through them and write their claim evidence reasoning, then having them do the reaction sorting activity through some breakout rooms or group discussions so that they sort of get the idea of the patterns that are going on and you can help them understand those. And then as an asynchronous, they can read through those chemical reactions and signs of a reaction. For live, going through this chemical reactions and identifying what reactions are which. Students often have a little difficulty getting started on that, so I would recommend starting that at least as a live activity. I then thought that introducing the mystery dropper lab might be a little easier than introducing the predicting products lab, but I would introduce one of them and then have them work through it as an asynchronous activity, then coming back together to sort of talk through the lab and then use that as a basis for how to do the predicting products practice. Seemed to make sense. Then there's a predicting products quiz you can assign people if you want to during the asynchronous, or you can give them some extra time to work on the predicting products practice, depending on how much time they need for that. I do, like I said, recommend doing predicting products practice because in my experience, they need someone to model what's going on. Um, every time I've given that to students in a live classroom, there's been, I would say a majority of the students look at it and go, I have no idea what you want me to do on this until I explain it. And then they can start working through it. And a lot of them will need will need help on that. Then the balancing equations PhET simulation, I would role model sort of how it works a little bit at the beginning, give them a little time to practice it in class, and then walk through how to balance at least one or two equations on the practice balancing sheets. Then let them do that as an asynchronous activity, but set up some group time for support for those people who don't quite get it. There will be a small, maybe depending on how your class runs, there will be some people that will need some extra support, but it won't be all of your students. So a small group help is probably what you need for once you've gone through that, because some people will get it. And then you're going to do a little bit, then you'll go through that balanced or unbalanced nitrogen cycle, and that'll give you a chance to go back and reteach some of that balancing equations if people need it, because you can kind of go through and talk through a few of those and let people finish out either the practice problems or the nitrogen cycle there. And then you can do some sort of asynchronous review or synchronous review and have your assessment. So that's what I would recommend for the unit calendar. Okay. At this point in time, I'd like to stop the recording and see if there are any questions that people want to ask. So I'm doing that now.